All right, we've made it, guys. These are the last notes of Unit 1. All right, so what we're going to do is the last notes we talked about were periodic table organization. We talked about how the periodic table is organized and the different group names and such. Today we're going to talk about the trends that we see in the periodic table. Okay, so let's take a look at those periodic table trends. Okay, so we're going to start with the trends going down a group on the periodic table. And remember, a group is going down a column, basically. So we're going to talk about those periodic table trends going down a group. So if we look at a group of the periodic table, what will we see? So the first trend we're going to talk about is the size, okay, the size of an atom. So as we go down a group, the size of an atom, or what we call the atomic radius, is going to increase. Okay, so we're going to have, the smaller atomic radii up, towards the top of the periodic table, and the larger, okay, or the big atomic radii down near the bottom of the periodic table. The second trend going down a group is the softness of the metals. So if you remember, the metals were on the left-hand side of that staircase on our periodic table. So the softness of a metal is going to increase as we go down. So that means that the soft metals will be down here towards the bottom, and the harder metals will be on the top. The third trend that we're going to talk about going down a group is reactivity. Okay, so how fast something, a metal or another atom reacts with something else. And reactivity is going to increase as you go down the group. Okay, so reactivity increases except for those halogens. Okay, remember the halogens are on this column here. Okay, this column right here, the 7th A group, and they are going to react in activity going up. Okay, so for the most part, on all of the other groups, the most reactive will be down here on the bottom. Okay, except the halogens, the most reactive is fluorine here, up here on the top. The fourth trend that we'll talk about going down a group is mass. Mass is going to increase as you go down. Okay, so this should be no surprise, because if you look at regular periodic table with all the information there, hydrogen, which is up here, is going to have a mass of about 1. All right, now when you get down here, okay, to radon, it's going to be like 290 something. All right, so mass again is going to increase as you go down a group. All right, now we're going to get into the more complicated trends going down a group. We're going to start with the first one called electronegativity. Okay, good word here. Electronegativity is a feature of an atom where it's the atom's ability to attract electrons to itself. Now, I know you've learned in previous science classes the parts of the atom, the protons and neutrons in the nucleus, and the electrons on the outside. Okay, we'll review those in some lessons in the future. But the atoms have electrons, and some atoms have an uncanny ability to attract electrons to itself, and others don't. And here is the trend for that. Okay, so when you go down a group, the electronegativity is going to decrease as you go down. Okay, so as an example, if we take beryllium right here, okay, he's going to have high electronegativity. Okay, that means he's going to want electrons. He's going to want more electrons. Okay, as compared to radium in the bottom here, who's going to want or not want any electrons. Okay, he's going to have low electronegativity. Now, we'll soon find out in a couple of lessons that the atoms here on, towards the bottom of the periodic table are much bigger than the top, okay? And they've got a lot more electrons. So it makes sense that they don't want any more electrons around themselves because they already have so many. Okay, so that's another way to think about it. The smaller the atom, the more electronegative, the more it wants more electrons. The bigger the atom, it's already got enough electrons, don't want no more. Okay, so we have a trend going down that electronegativity decreases. Okay, so the next trend we're going to talk about is ionization energy. Now, electronegativity and ionization energy go hand in hand, okay? Because ionization energy is the energy needed to remove an electron from an atom, okay? So as we go down a group, the ionization energy is also going to decrease, meaning that it's going to be easier, it's going to take less energy to take an electron away from an atom, okay? And that makes sense because, again, you know, the ones here up on the top have high electronegativity. That means they want electrons. They don't want to lose their electrons, okay? So the ones on the top, again, are going to have high ionization energy as well. That means it's going to take a lot of energy to try to remove an electron, okay? It's like taking a toy that a kid really likes away from them. It takes a lot of energy. It takes a lot of pulling in order to, you know, get that toy away from that kid. Okay. Now down here on the bottom, as it decreases down here on the bottom, you know, they're going to have low ionization energy. Okay. Because again, we can think about it. These atoms already have a ton of electrons. And so I always think about, you know, the kid, or not the kid, the parent, you know, at, you know, the zoo or somewhere, and she's got like 12 kids and trying to keep track of them all. It's very easy for her to lose one of them. You know, just like the bigger atoms down here have a lot of electrons, so it's a lot easier to take one away. It's a lot easier to lose or take away an electron. So they're going to have low electronegativity down towards the bottom. Okay, so electronegativity and ionization energy go hand in hand. They both have the same trend. They decrease going down a group. Okay, so our next trend is that atoms in a group have the same number of valence electrons. Okay, now again, this is a special type of electron that is around the nucleus. These electrons are in the outermost shell. Okay, and again, we will get to that. We will review that in future lessons. But just to know now that atoms in the same group will have the same number of valence electrons, and we can always look at our periodic table and know exactly how many valence electrons there are, because we look at the A group, okay, the number before the A group. So for example, it's kind of hard to see here, but this one right here, okay, this column right here is 3A, all right. Some periodic tables have them in Roman numerals, others have them in just, you know, plain numerical numbers. So you're going to need to know, you know, the Roman numeral counterpart for, you know, 1 through 8 at least. Okay, so 3A is going to have 3 valence electrons. It's as easy as that, all right? You know, group, this is number 6A, so that's going to have 6 valence electrons. Over here is 1A, so it's going to have 1 valence electron. Okay, so all of the ones in the same group will have the same number of valence electrons. All right, and last but not least, the last trend we'll talk about going down a group is that elements in the same group are going to have similar properties. All that means is that they are going to react similarly to each other, and they're going to make similar types of compounds. And we'll, you know, get to see that more and more as we learn more about the different atoms and the elements and how those atoms will react and combine with each other. Okay, but for now you just need to know that the elements in the same group are going to have similar properties. All right, so going across a period. Now remember, a period is a row going from left to right on the periodic table. So our first trend going across a period is that mass is going to increase. Okay, so again, if we start here with hydrogen, that's the smallest atom in matter, and it's going to have, you know, a mass, if you look at your periodic table, of 1.0, and if we go across over to helium, okay, it's going to have a mass of 4.0. So mass obviously increases, okay, as we go from left to right. All right, our second trend is size, or remember atomic radius, or the size of an atom. And the size is actually going to decrease as you go from left to right. Now you might think that's a little weird, because if the mass increases, shouldn't the size also increase? But size will decrease going left to right. So although size increases going from top to bottom, it decreases going from left to right. And that has to do with electronegativity. Remember, electronegativity is the ability for those atoms to attract electrons to themselves. These guys over here, we'll see, on the right-hand side of the periodic table, have higher electronegativity than the ones on the the left-hand side of the table. So the ones on the right-hand side over here are going to hold their electrons closer to themselves, making them smaller in size, okay? So these guys on the left will be a bigger radius, and these guys on the right will be slightly smaller radius because of the electronegativity of the atoms, okay? And in fact, that's the next trend that we're going to put down in our notes, is that the electronegativity going across a periodic table from left to right is going to increase. Okay, so here we have it in our notes right here, that electronegativity increases from left to right. All right, so if we were to compare sodium with fluorine, all right, sodium is going to have a lower electronegativity. Fluorine is going to have a higher electronegativity. Okay, so this would be low electronegativity, and fluorine would have a high electronegativity. Okay, and again, that's going to make fluorine, okay, a smaller atom than sodium, because fluorine is holding all of its electrons closer to itself, closer to the nucleus, okay, than sodium is, okay? And you should all remember what, a nucleus is, protons, electrons, and stuff. You've had that in previous science classes. Now we will quickly review them coming up here in the start of the next unit, but when I say those kind of things, you should have an idea of what I'm talking about. Okay, so again, fluorine will have a higher electronegativity, a smaller size, because he's holding his electrons closer to its nucleus than sodium is. All right, let's take a look at the last two periodic table trends going across a period. Okay, now remember, electronegativity and ionization energy, okay, are related. Okay, they are both related. They have to do with electrons being held tightly to the atom. Okay, so if we're going from left to right on the periodic table, ionization energy is going to increase, just like electronegativity increases. Remember, ionization energy is the energy that it needs or takes to take away an electron from an atom. Well, if electrons are holding their atoms very close to themselves because they have a strong attraction for electrons, that means it's going to be really hard to strip them away. Okay, so ionization energy is going to increase. That means the ones here on the right side of the periodic table, you're going to have a really tough time stripping those electrons away from the atom. Whereas the right side of the periodic table is going to be much easier to take away electrons from the atoms. Okay. All right, let's take a look at the last one. There are a lot fewer trends going across a period than down, so that's awesome. So let's take a look at our last trend going across. All right, so our last trend going across a period is that the number of valence electrons is going to increase by a value of 1. And we saw that in the last slide when we were talking about the group numbers telling you the number of valence electrons, right? So, the first group has 1 valence electron, the second group has 2. We skip those transition metals because they, that pattern gets screwed up there. The third group has 3, 4, and then so on up until 8. Okay, so each time you skip over to the next group or going across the period from left to right, the number of valence electrons is going to increase by 1. Okay, so those are the trends going across. Now the very last part of our notes is just going to be taking a look at kind of a picture of the periodic table trend on the periodic table. Okay, so let's just kind of put all of the stuff that we've said kind of in a picture for you visual learners here. All right, so here is a periodic table. On your papers, it would be awesome if you just kind of sketch the outline of the periodic table. Just kind of briefly, sketch the pattern here. We've got, the periodic table, and then we've got these 2 little columns down here. Okay. All right, so if we have, the outline of our periodic table, let's take a look at each of the trends and kind of, map on our periodic table, which area we're going to find the heaviest, which is the lightest, which is the biggest radius, which is the smallest radius, where are the hard metals versus the soft metals, and so on, so that we can kind of have a visual of what's going on here. We're going to start with size. Okay, so we said that the size of an atom increases going down, okay, and decreases going across. All right, so that means that over here on our periodic table, we kind of skip the noble gases because they're there, they exist, but they're not very exciting. All right, we'll see in future. But over here on the top right-hand corner of our periodic table, we're going to have the smallest radius. Okay, because again, the size is going to decrease as we go across. So that means the top right-hand side will have the smallest radius. And we said that the size increases as you go down. So that means down here on the bottom right-hand corner of our periodic table, we are going to have the biggest radius. Okay. All right, so we have our biggest radius down here. The next trend we talked about was softness of metals, and we said that the softness is going to increase going down, and so that means we're going to have softer metals down towards the bottom and the hard metals near the top. Okay, there is no trend for metals going left to right, okay, or across a period. It's just up to down. So we've got hard metals near the top, soft metals near the bottom. Okay. The next one we talked about was reactivity. And again, this is one that is only going down a group. There is no periodic table trend going across from left to right for reactivity. So going down a group, we said that reactivity increases for all of the groups except the halogen group. Okay. So that means down here on the bottom, okay, we have, the most reactive. Okay, so most reactive down here on the bottom, except for our halogen group. So that means that fluorine here is not only the smallest radius, but is the most reactive in its group. Okay, he is a go-getter. All right, so most reactive. Now the fourth trend we talked about was mass. And mass is going to increase both going down a group and across a period. Okay, so that means that hydrogen here is going to have, the least mass. It's going to be the lightest, okay, in weight or mass. And that means that down here on the bottom, radon is going to be the heaviest. Okay. So we're going to have the heaviest down here on the bottom because mass is going to increase going across and down. Okay, I had to clear my board here because it was getting a little messy, but you guys just keep on going on your picture and your notes, okay? To our next trend, which was electronegativity. Now we said that electronegativity is going to decrease going down and increase going across. Okay, so if we increase going across, that means, again, fluorine here, all right, he is a whippersnapper. He's small, but he's mighty and he's fierce, okay? He's like a little pit bull. All right, he is going to be the most electronegative, okay? So most electronegative. I'll just put a little negative sign there. So the most electronegative is fluorine. Again, we're going to skip these noble gases because yes, they exist. Yes, they have electrons, but they're quite boring because they don't do anything with their electrons. They don't lose, they don't gain. It doesn't matter with them. Okay, so we're just going to kind of ignore them for now. Okay, now we said going down a group, electronegativity decreases as you go down. So that means porphyrium down here is the least electronegative. Okay, so, oh, hold on, just a sec. Okay, so he is the least electronegative. Down here, porphyrium. So we've got two dichotomies here. Upper right-hand side is the most electronegative. Lower left-hand side is the least electronegative. All right, one of the last trends here is ionization energy. Again, remember this follows electronegativity because ionization energy is that energy needed to take away an electron. And if atoms are highly electronegative, meaning they are attracting their electrons, they're wanting to hold on to their electrons, they're going to have a harder time letting them go. So we're going to require lots of energy to remove electrons. So that means that fluorine is the most electronegative, okay, and has high ionization energy. I'm just going to abbreviate that as IE, ionization energy. And again, francium down here is the least electronegative. It doesn't want to hold on to its electrons at all. Okay, so the amount of energy it takes to take one away is very low. So this one is going to have low ionization energy, or low IE. Okay. All right, now real quick before we go, let's just review here. That remember there is this staircase here on our periodic table. Okay, actually let me do it in a different color. How about green? We have a staircase here in our periodic table. And remember that everything to the left of that staircase are what we call metals. Everything to the right of that staircase are nonmetals. So we can see that most of the elements that make up, okay, the Earth and the universe are going to be metal atoms. All right, and it had least abundance or at least different number of non-metal atoms. There's a lesser amount of non-metals than metals. Okay. And the red ones here are what we call metalloids. They kind of have properties of metals and non-metals at the same time. They're a little weird. But we call them metalloids since they're kind of metals but kind of non-metals. They're kind of in between. All right, so that is all of our periodic table trends, all in this nice, kind of visualized picture here. And again, these are the last notes of the unit, so you should be expecting a test sometime next week. So make sure that you prepare yourself for your test, do review sheets. You will have to study for chemistry, okay? It's not something that you just get. People don't just sit in chemistry and are enlightened like, oh, okay? You have to practice, you have to review, you have to look, over your worksheets, you have to look over your notes. Great way now that all of my notes are, me speaking to you on the computer, okay? Take a few nights and just, go through the notes again. Let me, retell you about all the stuff, or even just, the stuff that you're still struggling with. Replay the notes and take another listen at them. A lot of times the second and third time around, it'll start to click. Okay, so good luck studying for the test coming up, and we will see you tomorrow in class.